Hello everybody, my name is Miroslav Stampar and I'm one of developers on sqlmap open source security project made for detection of SQL injection flaws and their exploitation. So first of all, how many of you have used sqlmap till now? Okay. Not many. Okay. Who are we? We are a team of two members, two developers. One is project leader Bernardo Damel. He's quite famous at the team. He has lots of conference talks around the world. Maybe you've heard of him now. No. Okay. Currently, he lives in London, UK, but he came from Trieste, here in Italy, and currently he works for NGS Secure, one of biggest UK companies. One of biggest security companies in UK. Second one is me. I'm a professional software developer at automotive company AVL, branch Croatia. We are doing meshing of motors with internal combustion and simulation of those. But I was always inclined towards security stuff, so I needed to fulfill my childish dreams somehow. So this is a good way to fulfill them. So this is my first conference talk, and I'm a little nervous. So don't blame me for.
You're doing great.
Thanks. So, what is sqlmap? Officially, that is just a copy-paste from our web page. sqlmap is an open-source penetration testing tool, blah, blah, blah. But in plain language, it's all-in-one SQL injection tool. So it's not just about the detection, it's exploitation of the same. We have over 10,000 updates and or downloads monthly, which is a quite good number. And sqlmap is part of many popular security distributions around, such as Backtrack. You know what is Backtrack? Backbox, Web Security Dojo, OWASP, and so on. Short history. Guy named Daniel Bellucci. I didn't meet him. I know what our history file says, and it says that he started the project officially July 25th of 2006 by registering it to the at the SourceForge as a new project. He worked on it for a few months. It was, from my point of view, it was quite. He worked quite good, but at some point in time, I don't know why, he left the project, and Bernardo took it over. They were friends, and Bernardo just said, "I'm in that field of security, and I would like to continue it." So. He worked alone for some 3 years, and that's quite hard thing to do. Working alone for 3 years, he had even RenMine page where he stated all the faults and all the fixes he did. He did it just for himself, and he did it quite fine. And when I replied to his call for developers, we just continued it. So he's quite quite a decent project leader, I should say. There is a anecdote how I started, how I replied to the call for developers. I always wanted to, I had an urge to be a part of open source community, and I started to look around the projects, and I always wanted to be part of some security stuff. And I know that at some points in time I did some dummy testing, some SQL injection stuff, like everybody. And I recall that there was a cool tool, and I saw Bernardo's call for developers, and I was all excited, and I replied to him. I started to work, and after a year of time, I didn't tell him. So this is the first time that I'm telling this to anyone. It was totally different tool. So I was amazed that a different tool called Squid, but I somehow mixed those two. So I started working here, and you see it's almost 2 years. So we did a quite good job at those 2 years. So current status, stable version is 0.9, but we are actively developing on version 1.0. We have a powerful detection engine. It's not my words. It's something that can be read all around the web. We did a quite decent job here. We spent tons and tons of hours here. We have a state-of-art enumeration engine. I shouldn't go much in detail here because it's quite tricky part, and I shouldn't bother with you here, but you should know that we really do a good job at that enumeration. So you have a detected SQL injection flow, and you have to use it somehow, and that's called enumeration. You need to recall some data from backend DBMS with that same flow. Then we have takeover functionalities. You know what is Metasploit, and we are quite good integrated with it. Also, we have some web shells, web backdoors, which we upload via the injection. So we give to user the full takeover, full privileges on that backend system. Then we have support for intrusion detection systems and web application firewalls in form of tampering scripts. So there are more and more requests for doing this kind of stuff, because lots of companies now, it's a sad fact, but they don't patch their SQL injection flows. They just use some famous IDS like PHP IDS or some ref, and they just put it between the attacker and them, and they expect that third-party tool will provide it defend from the hacker. But there are lots of ways how to evade those, and I will introduce some of those at the end of the presentation. Also, there are numerous optimizations like multi-threading wherever we can, keep alive, no connections and stuff like that, remote file manipulation like file reading and file writing, and brute force methods. Brute force methods we'll come to those, but just in short notes, there are DBMSs around that don't, from which you cannot enumerate the names and of identifiers of the tables and databases, and you need to brute force them to be able to dump those rows which are presented by those same identifiers. And we are doing quite a good job here regarding column naming and brute forcing of table naming. Also, here I can mention the hash cracking. We'll come back to those later on. Show future GUI. Lots of people are bothering us, so we need to make it. So it's a top priority here. We need to provide some kind of professional reporting. We have lots of knowledge acquired through years, but people don't like to see just the listing of the command line execution. They want some solid stuff where they said that and that tool said that and that, and we can provide report which can say this and this is affected by this conjunction. Do that and that. Please make sure to switch these switches on and blah blah blah. Auto band and advanced techniques. Support for few DBMSs left. We have a quite huge list of DBMSs which we provide the enumeration, fingerprinting, but there are still DB2 and Ingress and I don't know, few of those which we need to stick it in future. Generic lexical parser. Thing is that it's quite hard to differentiate if something is a scalar value or something is a vector value. With scalar value, you have just to make a one call and you will come back with that same value. But with multiple row value, you have to enumerate column by column of that same column. So we have to right now we have some clumsy way to differentiate those two, but we thought of doing some kind of SQL parsing for doing that kind of stuff. Advanced TDS VF evasion techniques, I'll come back to those later, and upgrade to Python 3. These are quite painful subject for lots of open source projects around. So lead project statistics. Python and XML are top two languages used in the projects. You can see that those two combined are 88% of the project. You can see down there that lines of code through the period of time. Here was the start of the project that Daniel Bellucci did a quite good job alone. Here was Bernardo alone, and here we combined our forces and project went quite up. Some of features, fully supported DBMSs. Here's a full list, and by that list, I can claim that we support for what is supported by MySQL. It's supported by all others. So lots of tools around claim that they can do stuff from this, from MySQL, Oracle, Microsoft Access, and stuff like that. But they can provide things like fingerprinting, but dumping is quite hard on few of those. And I will introduce you to to the method of pivoting which we used for those obscure DBMSs. For support SQL injection techniques, those 5 are the most, they combined they are 99% of SQL injection flows are affected by those 5 techniques. Then enumeration of database users, users password hashes, privileges, roles, databases, tables, and column names. Then recognition and cracking of password hashes, web server file upload download, I already mentioned that. Arbitrary command execution and retrieval standard output, mostly through web shells and web backdoors uploaded via our tool, and establishment of out-of-band TCP UDP connections. This is mostly done via Metasploit. We upload their package to the backend server. We run it, and we just leave it as it is to connect to the server on the attacker's machine. Community, we have a quite huge pool of beta testers around. This moment 200 subscribed. Every day there is 10, 20 different suggestions, bug reports and stuff like that. Lots of various colored heads around. Me and Bernardo like to spend some time when we meet. We like to talk about some of those people. There are quite few of those obscure people around that are messing around the mailing list. They all provide indispensable help by reporting bugs. There are lots of obscure cases that us two can't get to. We can't test every possible way of running the program, but having around 200 testers, active testers, is a great help for us. There are lots of feature requests, lots of things we've done which can be claimed revolutionary. Can be all we can be thankful to the users which requested that features. They are keeping morale high, and some modest donations are around. So this SQL injection for dummies, for all of you that didn't see this kind of stuff. This is PHP with Postgres as a backend DBMS. You can see here that you have a standard query, select blah blah from products, product ID equals to concatenated value of the provided get parameter ID. Attack vector could be something like this. So instead putting ID equals 7, you can just put I don't recall the name of the semicolon, drop table users, and resulting SQL statement would be something like this, and you would just lose all the content of your table users. I don't know if you followed the scene last few months. You probably heard of lulsec, and yeah. So thing is that stuff is getting pretty hot last few months. It was quite sporadical, like you see here. Okay, there was that kleptoman Albert Gonzalez, 130 million credit cards were lost, but you can see here 2007, 2009, 2010. HB Gary, MySQL, Commodore, and this is all just in last few months. With Sony, you have 20 sites and counting in last month. Fox, Sony, Infragas, Nintendo, CNN, and that's all. Those all were affected by SQL injection flows. So you can see that this is a quite a hot topic now. Also, there is something called SQL mass injection around. Lisa Mon is a good presenter here. You can see 29th of March, it had 2 to 6,000 sites were affected, and after a few days there were 1 million of those. So it's quite nasty thing around. And I found this random quote which best describes the current situation. So structured query language is becoming a Achilles heel of the internet. You probably know this. So I don't know if there are some of you that needs explanation of those, but as you can see, SQL injection is also going part with the popular culture, as X said there. Then there is funny sweets, anecdotes. Some dude that on the recent elections put those values, and one of those values were pawn drop table while is a Swedish for elections. So and I don't know how many of you own the websites around that can be affected with such thing, but this anti-chat is a quite nasty group of people that are not chatting like normal people, like using subjects and verbs and stuff like that. They all do just putting found targets. So if you own a target, you should spend some time and search around that anti-chat forum. Maybe you are there. So right now you can see there are 40,000 targets there. They don't do anything with those, but they put it there for potentially usage by some bad people. So for uploading stuff like, I don't know, PHP shells which can be used for flooding and stuff. Okay, now it's good that I've put some info on the techniques itself, because I don't know how many of you can say that they really know 50% of the topic. So now, so it goes like this. We have five major techniques around. First one is known as the Boolean or blind base technique. Also, part of popular culture call it 1 equals 1. 4 out of 5 vulnerable cases are affected. Thing is that we are trying to force the web server to change the appearance of the page if the response of the data or the request is true, and versus the response if the response for the request is false. So for every bit of information we are extracting, we are forcing the web server to put something that is similar to the original page or totally different. Yeah. As this Python conference, you probably know the difflib module. Difflib is a quite quite good model for doing this kind of stuff. You just say it, compare me this with that. It will say, it will tell you amount of or ratio, how much how much two pages are similar. So if the ratio is quite low, they are quite they are unsimilar. If it's quite high, they are similar. So for true responses, we want our ratio to be as high. For false responses, our ratio should go down low. This is a manual example. You can see here a normal request, ID equals 1, to result with something like this. If you say end 1 equals 1, it will result as the complete same response. But if you say end 1 equals 0, it will result with something totally different. And that's the core of Boolean or blind-based technique. What's the point? We will come to the point. I will show you a few examples how to use those. Error-based technique, we are provoking the error messages from the server. And thing is that we can provoke error messages in such a way that it can have the results of the query we want. So the most popular way for error-based technique is to convert some kind of string to the integer. So you put a select into the convert function, and you say, give me the password of that user and convert it to integer. And the web server will respond, I can't convert that's a string, and it will tell you that same string. And that's the point of that error-based technique. This is an example. You can see here we are converting version. Version is a global variable. We are converting to the integer, and the server will respond with something like this. I cannot convert it to the integer, and it will say Microsoft SQL Server 2005. Everything will be here. That's it.
And that's why I'm trying to get error codes. Okay, if I put a number here, I get an error, so this is a
That's it. So basically you can put anything here which is a string, and it will say you the result of that subquery here, that I cannot convert that string to the integer. Anything you can ask him for passwords and stuff like that. Union query technique. This is the fastest of all techniques. It combines the original results with the new results we want. So basically we have affected query, and we use the union to append some new stuff inside. So here you can see this the simplest case full union query technique. Where you just say union all select. You see here ID, name, surname from users, and it will drop down all the content of that users table. Partial one. These are more complicated. Partial union query is for the case when the web server somehow limits the output of the results. So it doesn't enlist the all rows. It at least only the first one. So we are deliberately putting here something illegal to analyze the original response and put something that we want. We get something like this. Time delay based technique, same stuff as blind based. Only difference is that you don't see the difference on the response pages, but you see the difference in the response times. Here you can see one example, and 1 equals to something which sleeps, and this will delay the response for 5 seconds. You will see how to use it later on. Stack query techniques, same stuff as timed. Only thing is that you just put here something behind the semicolon. And this the basic working examples you want to see. This is the stuff. You are asking what's the first character of the password from users. So first password from users, first character. You see here option 0, limit 1, first char length 1. And you ask if it's greater than, this is for this ASCII code for monkey char. So you are asking him if it's greater than that monkey character. And if the response is true, you know that character is something at the higher level of the ASCII table. Error-based technique, you can see here, say password for public users. We deliberately put here, we are concatenating here some prefix and suffix to be sure that that concatenated string will be something non-integer, so that we are sure that this will be for sure trigger the error response. Union query, something like this. Time delay based. Time delay based. You can see here, we are using case. If that first character is something greater than that monkey, then do nothing, do a dummy select, else sleep. So we will detect those sleeps and we will reconstruct the characters by those responses. Stack query is the same stuff as time delay based. Only thing that is you don't put here, you just put semicolon and do the new select. Okay, something about the program structure. I wouldn't go here in much details. I'll just do a quick overview. We put everything doc based into the doc directory, manual, thanks, change log and stuff like that into the lib. There are core modules and there is a core core engine inside. In extra, we put third-party modules. In plugins, we put DBMS specific modules. So for every new DBMS, we put a new plugin inside, which tells how to detect that same DBMS and how to enumerate it. Because every DBMS has some specific stuff which needs to be used. Then in shell, we put stages and backdoors for those out-of-band connections. In Tampar, we use those. We put those tampering scripts for bypassing the firewall. In TXT, we put all these user agents and stuff like that. In XML, we put queries and payloads. This is the core of the SQL map. This is the engine, but this is the whole knowledge of the SQL map. So if any of you plan to rewrite it or steal something from it, this is the knowledge. So by using this knowledge, you can do lots of stuff. Programs workflow can be described something like this. We have a pretty huge setup, so there are lots of stuff that needs to be configured, lots of connection-based stuff, payloads and queries for those XML files needs to go to some proper structure where we can easily access them. After that setup, we have detection phase. We have those 5 major techniques. After the detection phase, so after we detect the SQL injection, we are going to the fingerprinting, because now we know that server is affected, but we need to know what is the backend DBMS, so we could enumerate it, because every DBMS has some specifics. So after the fingerprinting, we do the enumeration, and takeover is optional. So you see here, we can read registry keys, give file access to the user. That ECMPSH is an UDP reverse shell. Metasploit gives you a TCP reverse shell, and web shell, you know what. Development environment is consisted of something like this. We have a subversion. As there are 2 of us, we don't need Mercury and stuff like that. Subversion is quite decent. We use a Redmine for project management. We are based on Python 2. We don't plan to move to Python 3 some short period. Text editor of choice, debugger of choice, and Testing environment. We have 2 testing machines. One is Linux machine and one is Windows machine. We use that Linux machine quite often. It's light, small memory footprints. We use it quite a lot. And now, now this should be the core of the presentation. Now I'll go to the highlights. I can say that those are revolutionary things, but these things combined make a SQL map a really great tool for doing this kind of stuff. Inference is nothing revolutionary, but for those who don't know, that is basically a binary search. So when you want to know what's the first character of that password, you can go and ask, is it A, is it B, is it C, is it D? But you will have to go to the whole ASCII table to find the character. So complexity will be something around O and divided by 2, which is quite slow. But you have that binary search principle where you have the table, and you say, you ask if that character is something in the upper part of the table. If it's true, you just shorten the table and just use that upper part. Then you say if that same character is something from that upper part of this, and if it's false, you will just use that lower part of that same table. And at the end, you will come to the table with only one character, and that only one character will be that resulting one. That's called inference. Character prediction. Thing is that in dumping of particular identifier names and system stuff, there are lots and lots of repetition going on, like create synonym, create table, create trigger, stuff like that. And we came to the idea to use something called dynamic prediction tree. So we get the first character, and if we see, we have the list of all common stuff used by all our DBMS supported. And we just create the table or tree, and we just decide what's the best, what's the highest probability of the next character involved. So if you have this as common stuff used by DBMS, and you know that the C is first character, you can quite easily spot that they all share the R as the second character. And so we know that if we ask if that character is R, that it will have a high priority to not go through all that table, but just to spot that character there. So you see here, we are going to the create part of tree, and we came here with the S T T U V. Now we know that the highest probability will be based around these characters, not the whole table, but these characters. And we will ask if the character is something from the upper part, like said in that inference part. No? No connection. Thing is that there's quite nice article around that says that you don't have to get all the page content to be able to compare those contents. You can only get the sizes of those pages and compare those sizes. And thing is that, for example, on Apache, if you put a header called range, and if you put bytes equals to -1, it will just reply with something like this, without any body. So you can imagine what's the speed optimization of this method. So if the original page was something around 75 characters long, and you get with the response for your injection that this is 75, you know that this response should be true. And if you have something different than this, like in this part, you know that it's false. In IIS, instead of range, you use the method head, and you get just the response, something like that. Content minus length with the length of that body, which is not applied to this. So we are just keeping the huge bandwidth loss around and use this stuff. The amnesty removal. Thing is that when you compare two pages, and if they have lots of JavaScript ads and banners inside, you probably notice that after a few seconds, pages just differ somehow, and that causes trouble. So in normal situations, it's very hard to distinguish at the Python level, at the difflib level, if those two pages are same or different. So are we talking about the true or true-false responses? And we came to the idea to remove those dynamic parts. So we are using, again, difflib, and we compare two pages which are retrieved with some period of time, few seconds, and we get with the difflib, we can get the matching blocks from those two pages. And we know that those matching blocks are static ones, but there are those between those are dynamic part. So using the regular expressions, we can distinguish later on what is static and what is dynamic. So using something like this, we can just remove those parts which are marked with this regular expression. Reflective values. Thing is that in some cases, pages like search pages, just put something like, if you use this as a query, it can just return this inside the page's body, and this gives a headache for detection part. And we are using something we are using method to remove those reflecting values by using regular expressions the same way as we use it in those removing of dynamicity. So we put here something, those characters we know that won't be encoded in any way by the web server. So characters, plain characters A to Z and numbers. But those special characters like spaces, we know that there is a high probability that they will contain something like that. So we use regular expressions like this to distinguish if there was something like this reflected in the responses body. If it was, we just remove it, and it gets the job far easier for detection if something was injectable or was not. Statistics. Maybe this is the most revolutionary thing in sqlmap. Thing is that lots of tools have problems with detection if something was delayed or not. So lots of tools say to the backend server, give me a sleep of 1 second. And if there was some kind of lag in connection, or there was some kind of, if there is a lag in connection, those tools can't distinguish if something was delayed or something was not delayed. So if you say sleep me for 1 second, and it doesn't sleep for 1 second, but it lags for 1 second, then you will have problems. But here comes the statistics. It says something like this: you collect the good amount of normal responses, and you know that they will come to this normal distribution here. And everything that is outside those distribution, you can just tell that it's not normal. So we collect normal responses in those delays. So we collect normal response of the web server, and afterwards we put a request to the backend server, give me a delay of 1 second. And we know that there will be quite good chance that if a backend server really delays, it will go outside that curve. Thing is that statistics says that normal data should go inside 7 times standard deviation of all those data. So thing is that we collect all the normal responses, and afterwards we just compare those injected responses with those normal responses. If it goes inside, we know that was a normal response, it's not delayed. If it goes outside, we know it was delayed response. Same thing we use for the detection of union injection. Thing is that there is a quite good chance that if you say something like union all select null, then in second request union all select null null, then in third request union all select null null null, there is quite good chance that if the target is affected by the null injection, that the response with the right number of columns will stick out. So it will stick out somehow. We don't know how, but if we compare those all responses, and we just say in normal times, this will result in something erroneous. In normal times, this will result in something erroneous. But that one with the right number of columns will somehow stick out and just go outside this normal distribution curve. And we will know that that was the right number. Then false positives. This also gives a headache to lots of tools around. We use a quite childish approach. We are using simple arithmetic tests just to see if there is some kind of intelligence at the end. So time and stacked injections are, even with usage of those statistical methods, it's quite nasty to deal with those if there are significant lags. But afterwards, if our engine just says your target is affected by timed, we know that there is a quite good chance that it's a false positive. And then we say, please give me an response for those arithmetic tests. And this, in 99% of cases, if there is a false positive, it should just fail on some of those tests. If you see something like this, 1 + 2 = 3, this should result in true. If it results in false, then we know that it's a false positive. Afterwards, this should result in false. If it results in true, we know it was a false positive. So we have those four tests with random numbers, and there is a quite good chance to spot the false positives with this approach. Heuristic test. This used by most of tools around to spot if something is SQL injectionable or not. But it's quite insufficient. Thing is that you put inside the parameters values, you put some blatant invalid SQL injection characters. Something that will for sure cause trouble if this is injectable. And if there is some kind of error message inside, then we know that there is a quite good chance that this is SQL injectionable. Things that we use this knowledge like this, not to say that something is SQL injectionable, but we parse the error messages inside, and if we notice that it is something similar to the mix of SQL Server, then we know that we don't have to test all, 100 tests that we have in our payloads file. We know that we will just need to use our Microsoft-based tests, and it will noticeably shorten the time of tests. Temporary scripts. This was a result of request of one of our users from the mailing list. There are lots of intrusion detection systems around that can be quite easily circumvent with this kind of conversions. So it will notice this, it will detect this, but it won't detect this in some cases. Then this was the first temporary script we used. So user requested that his backend server noticed this, and he had problems with injecting this kind of values, and we needed to make some function which will transform this into this. And if you notice from the syntax, this is the same as this, but there is no this character which was in his case filtered by his firewall or intrusion detection system. Also, this is quite popular, moving of putting. What? This is used in when we are using that inference. So we have a table which we know that should be a positive value inside. So it goes from 0 to 235. Also, this is a quite popular technique. Just putting of these dummy comments between the keywords will just screw some EDSs around. So it will notice this. It will detect this, but it won't detect this because there is no white space here. So currently there is 14 of those tampering scripts around that some advanced users use for bypassing EDS around. We are planning to do the automation of these features in some near future. Thing is that there is a quite nice method how to spot if something is affected by this or not. I won't go into detail. So we'll provide to user the functionality to automatically try these tampering scripts to bypass those intrusion detection systems. Pivoting, lots of DBMSs around don't have something like this, limit offset. And this is quite important stuff for dumping data. So you want a second column from second row, for example. And there are DBMS around like MS SQL doesn't have this, where you have to emulate somehow this mechanism. And we use the something called pivoting. So we use one column. In most number of cases, it's something like ID. So we use one column. We retrieve its value by using this. Give me a minimum value which is greater than the previous value, and we just retrieve those values of that pivoting point. And afterwards, using that knowledge with those pivoting points, we just retrieve the other column values by using this, where pivot column equals to that current pivot value. SQL harvesting. As said at the beginning, there are DBMS around that don't, where you cannot enumerate the column names and table names. So you have to do some kind of brute forcing. This is some method of brute forcing. How to brute force if the table name from the DBMS around. Thing is that if table name exists, this will just be true, and exists, select mark from that table. But if it doesn't exist, that table name, this will somehow crash. It will result in some false or erroneous page. Also, with columns, same principle. Thing is that we use Google for harvesting those common table names and column names. There were a large number of SQL files around, and we use lots of regex and stuff, and we just use those high frequency one stored inside our textual files. And when we use switch file like these common tables, we just use here those collected names we collected before. So hash cracking before or with other tools, you have to collect those hashes and put somewhere for cracking. We support 10 different 10 different hashing techniques like MySQL, all MySQL scheme, MS SQL, stuff like that. We collected high-quality dictionary word lists with 10 megs of keywords inside. And when we detect in the dumping phase something, when you collect something in the collecting phase that is similar to the hash, we automatically crack it with usage of those hashing functions we have. And they are quite fast because coroutines are coming from hashlib, like MD5 and SH1. So quite fast because we are using hashlib and they are binary compiled, so it's quite fast. No. For example, on my machine quad core, you have I don't know, 2 or 3 different hashes. With that word list of 10 megabytes, you need something like about 5 to 10 seconds. Yeah, and everything is automatized. Then we have those quality tests. We need it because there are only 2 of us, and we tend to screw things up. So we have live tests. So this is something like batch-like workflow, which is declaring instruction XML file. We just run it, and it just runs the tests against our virtual machine. And if it crashes, then we know something is wrong. Smoke tests is a dummy finding of all modules and importing of them. And spylint, you know what spylint, lexical analyzer, quite good. So that's the best self-protection advice for the end you can get from me. Use the parameterized SQL statements. Thing is that lots of people sanitize database inputs by themselves, and there are lots of temporary scripts waiting, like you've seen, that can just circumvent those methods you used. But if you use something called parameterized SQL statements, you just tell the underlying library or functions of your, I don't know, database connector to treat those parameters provided as the values. He knows that if you provide here something that is not a value but an SQL statement, he knows that he won't try to run it. He will treat this as a value, not as a SQL statement. Problem with the SQL injection is that you are appending the something that should be a value, but bad people append new SQL statements instead of parameters. And thing is that in those parameter SQL statements, that underlying like Python DB API, make sure that those parameters are parameters, not the SQL statements. That's the best advice you can get. And questions? This is my first conference. I was quite nervous, but I hope that you will remember some stuff from here, especially that parameters. Believe me and Bernardo are quite good at this kind of stuff, and parameterized SQL statements are something that we cannot break. So, do you have any questions? At the end, just a second. join the project. These all links where you can find us. So if you have any questions, so if you get an urge like I did before joining this project, you can freely contact us both via this email address, and that's it.